So rate redox reversible, we were doing this exercise assignment. We did the 27 questions. So question 28. In this reaction, there is a change in concentration of a product with time as shown by the dashed line. As you can see, the concentration of a product initially it increased rapidly and then the rate has decreased and eventually it's constant. So the question is, the change in concentration of a product over time is shown by the dashed line. Now, what will happen if we what will happen if we change the temperature or if we increase the temperature? So increase in temperature increases the rate, but not the amount of a product. So in that case, B will be the right answer. So how increase in temperature affect the rate? It only alter the rate, but it does not affect the amount of product. In question 29, Maxwell-Boltzmann distribution graph, which is used to illustrate the effect of increasing temperature on a chemical reaction. The question is, which area on the graph indicates the increase in number of the molecule that has sufficient energy to react? So which area, like example, at when the temperature has changed from 400 to 420 Kelvin. So initially, when the temperature is 400 Kelvin, these are the particles which were reacting, already reacting, D. But when we increase the temperature, what is the area after the activation? So this is the extra additional area which has increased. Total area will be C plus D or B plus C, but they're not asking the total because they're asking which area on the graph indicate the increase in number. If the question was which area in the graph indicates the number of molecule have sufficient energy to react. If that was a question, then we'll say C plus D. But because the question is not the total, it's about how many particles have an energy which have increased their energy to react. So that's why it's only area C. And if this was the same question and they mention number of molecules that have sufficient energy to react, then this C plus D will be there. In question 30, hydrogen and iodine gases are mixed at 300 degrees centigrade and allowed to reach an equilibrium. The forward reaction is exothermic. What would you see if the equilibrium mixture was cooled to 250 and the equilibrium is allowed to re-establish? So if we cool down, because the forward reaction is exothermic reactions, if we decrease the temperature, equilibrium will shift towards the right-hand side, means the yield or amount of a product will increase. So means the equilibrium will shift towards the right-hand side. But we have the colored substances are also there. And then again, it reaches the equilibrium. Like first, when we reduce the temperature, equilibrium shifted towards the right-hand side, so the color will get lighter. But again, the allowed to re-establish means again it reaches the equilibrium. So once it reaches the equilibrium back again, then what will happen? There will be no visible. If the equilibrium, like initially, but because we are allowed to cool down, so the colorless substance is forming more and the purple substance amount is decreasing, but still, because it's a reversible reaction, it's a reversible reaction. So when it is a reversible reaction, we have both reactant and product. So as a result, what will happen? The color will get lighter. So no visible change is when there, because initially there will be a change and then again it will return back to the equilibrium, then there will be no visible change. But initially what will happen when we are decreasing a temperature, the equilibrium will shift towards the right-hand side. So amount of a product will be more and amount of reactant will be less, and then it reaches equilibrium. The equilibrium mixture at 300 was compressed. So if we compress, look, we have 1 mole here, we have 1 mole here, and we have 2 moles. So total 2 moles in reactant product. So the equilibrium will not shift. There is no change in equilibrium because we have equal number of moles. But the thing is, we compress. So when we compress a gas or gases are compressed, so the particles will come closer to each other. As a result, when the particles will come closer to each other, what will happen? The color will get darker. Because like if you have gas in which the particles have large spacing, if you compress the gas, so the particles will be closer to each other and they will have a like dark color. So as a result, the mixture will go dark purple. The mixture is not going dark purple because of shifting of equilibrium towards right or left. The equilibrium does not shift at all. The equilibrium remains. So equilibrium will not shift, but what will happen because we have increased the pressure, so the gas is compressed. So as the gas is compressed, the color will get darker, like the particles will be closer to each other. In question 31, a concentrated solution of a bromine water is orange. The following equilibrium exists. What would be the effect, if any, on color if 5 drops of sodium hydroxide is added? If sodium hydroxide, we have to check which substance sodium hydroxide is reacted. Sodium hydroxide is an alkali. So alkali can react with an acid. So where we have acid, we have hydrogen is best. So as a result, what will happen? Because this hydrogen will react with sodium hydroxide. So amount of a product decrease. If amount of a product decrease, where the balance or equilibrium will shift, it will shift towards the right hand side. But it's not like all the substance will be colorless because it's a reversible reaction. So we'll have both reactant and product, but amount of a product will increase and amount of reactant will decrease. As a result, the solution will become lighter or paler. So that's why B is the right answer. So you cannot say the solution will be colorless. Why? Because it's still the reactants are there, but amount is lower. The diagram below is a Maxwell-Boltzmann distribution molecular energy. If a temperature was raised, if you increase the temperature, where the equilibrium, where the peak will shift towards right, and the height of the peak will decrease. So where the peak will shift, it will shift towards the right hand side and it will get lower. So peak will shift towards right and lower. So that's why D will be the right answer. And if we increase, which of the following will shift activation energy towards left? So if we want to lower the activation energy can only be lowered by using a catalyst. Like this activation energy can be lowered by using a catalyst. Rest all of them cannot work. So if you use a catalyst, the activation energy will be lower. So addition of the catalyst. Next is question 33. Oxidizing agent oxidizing agent suggested was sodium dichromate. In acidic solution, a complete and ionic half equation. Give the oxidation number of the chromium. First, how to balance the redox equation? Look, first we start balancing with oxygen. And to balance oxygen, we balance water. Like how many oxygen are there, we will balance by same number of water molecule. So how many oxygen do you see? 7 oxygen on your left. So you will put a 7, you will balance oxygen. To balance the hydrogen, if you want to balance the hydrogen, we add protons. So how many hydrogen are there? This 7 multiplied by 2 makes 14. So we have 14 hydrogen. So we put 14 here. Hydrogen is also balanced. Then we balance the other element because chromium 2 here. So we put 2. Chromium is balanced. Then the net charge should also be balanced. To balance the charge, we add electron towards the side where we have more charge, greater charge. Here the net charge of a molecule is -2. Here net charge is +14. And here the net charge is +6. Here net charge is 0 because of water neutral. So on our right hand side, we have a net charge of +6. So on our left hand side, we want the net charge to be +6. -2 plus 14 makes 12. So how many electrons should be there? So we should have 6 electrons because each electron is -1. So 6 electron will be -6, -6. So we have total net charge +6 on our right and we have +6 on our left. Then the oxidation number, how to work out the oxidation number? If you want to work out the oxidation number for chromium and chromate with a net charge of -2. So each oxygen is -2, 7 oxygen will be -14 and this is 2x. So when we simplify, 2x minus 14 is equals to -12. Equals to -2. And this 2x is equals to -2 plus 14 divided by 2, which is equals to +6. So this is +6. So this one is +6. And here chromium, what charge, when it's an ion, like ion existing as an ion, the charge which is written same as the charge which is written is same as the oxidation number. So if you want to work out the oxidation number of a chromium, Cr2O7 has a charge of -2. We don't know about chromium. 1 chromium is X, so 2 chromium will be 2X. And oxygen is group 6, so each oxygen is -2, so 7 oxygen will be -14. So the resultant 2x minus 14 should be equals to -2. When you simplify this, -14 will go other side, it will be +14. So -2 plus 14 and 2 is multiplied, other side will be divided. So when you simplify, you will get +6. And this will be +3. Then the color, you have to learn the color. If it is a dichromate, then it will be orange. If it is chromate, it is yellow. And if it is chromium +3, it will be green. You have to learn the color of these compounds and their ions. So if it is dichromate, it is always orange in color. If it was chromate only, then it will be yellow. And if it is chromium 3 is there, then it will be green. So this was question 33 from the exercise rate, redox and reversible.